Merci d'être venu, hein? Heureux de vous revoir tous. On n'a pas beaucoup de temps, on n'a pas de temps suffisant, alors je vais vous adresser en anglais, parce que le français, c'est pas ma langue maternelle, mais quand même, si vous avez des questions, n'hésitez pas à me les poser en anglais ou bien en français après, et je serai heureux de vous répliquer. Allez, my name is Josh Long, thanks for coming. I'm so happy to see you. All of my information is there. Wow, can we turn off the lights a little bit? It's so hard to see the slides. Whatever. We have a lot of code there. So if you have questions, comments, feedback, find the code there. Also, my coordinates, my information is there. I'm online. I'm happy to help. How many of you are on Twitter? I'm just curious. Twitter, 2018, almost 2019. Twitter. All right, the rest of you, get on it. What are you doing? It's a great place to be. It's the new IRC. It's where the developers that drive the open source that powers your businesses are. A little bit about me. I work on the Spring team. I'm an open source engineer and contributor. I've done training videos, lots of different training videos in Safari. I wrote a book called Cloud Native Java, and this book is all about how to build applications that survive and thrive in the cloud. It's something about which I'm very proud. I found out, I was in Russia last week, I found out by accident that this book was available in Russian, and I did not know that. So that's interesting. And there's other ones coming. Maybe there's one in French. I don't know. We'll see. And then, of course, I am writing a new book called Reactive Spring. And really, that's the thing that's most important. That's the thing about which we are going to speak today, is Reactive Spring. We're going to talk about building microservices that are intended for production, but that use reactive programming. Okay, and this is an important thing because as you start to build more and more microservices, as you start to add more microservices to your system, you start to do more and more input and output. You move more data across the network. And this movement of data across the network traditionally requires or uses synchronous blocking I/O. So this means that when I want to send data from one node to another, I have a thread, and the thread is being used for as long as I am sending data back and forth. The problem with this is that having threads is expensive. It costs a megabyte of heap for every single thread on the JVM because each thread is mapped to a native operating system thread that is scheduled by the operating system. This is expensive, and this means that practically speaking, realistically speaking, there's a limit to how many threads a Java application can have today. One way to solve this problem is to be more efficient with our threads, to do more with the same number of threads. If we can find ways to move work off of our threads, then we can reuse the threads that we have and do more things with them. So one place where we can move work off of the threads is with input and output, right? We can use asynchronous I/O. This is not a new idea, right? Asynchronous I/O has been supported in Java since Java 1.4, right? Java 1.4 came out in 2002. It's been a long time. And yet, my guess is that you are not all writing your code using Java NIO channels, are you? Do you go to your work and start solving problems with Java NIO as your first import? Of course not, right? We think about the world in terms of the frameworks that allow us to deliver business value. We think about them, oh yeah. Oh, very good. We think about them in terms of the higher order frameworks, the computational metaphors that allow us to describe our business logic and our business domain and our world. But that has to change in order for us to be able to do what we're trying to do, to be able to reuse these threads more efficiently, to map to asynchronous I/O. So today we will talk about reactive programming, and we're going to do so, of course, in terms of Spring. I'm going to do so, of course, using my second favorite place on the internet. Not my first, my second favorite place. Start.spring.io. How many of you know start.spring.io? Je me demande. Okay, very good. That's not enough. It's good, but it's not enough. We need to make sure we're all on the same page. This is my second favorite place on the internet after production. I love production. You should love production. You should go as early and often as possible. Bring the kids. Bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. And if your children are restless and cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse and WebSphere, start.spring.io. So we're going to build a new application today. We're going to build an application that uses the reactive, we're going to build an application called the Reactive Reservation Service. We're going to use Spring Boot 2.06. That's the, I guess 2.1 just came out today, but I am going to use 2.06 because that's what we had yesterday, and I know that works. We're going to use the reactive web support in Spring Boot. We're going to use some sort of, we're going to use Lombok, right? We're going to use Lombok because Lombok makes Java a little bit less painful. There's a lot of good choices here, Java, Groovy, Kotlin, all of them good choices. I'm going to stick with Java just because it's very popular. I need actuator for observability, that's nice. And I want some sort of persistence option. And so I can switch to the full version. And when I click the full version, I'm given an ocean of checkboxes. I see here a column called SQL. These options, while they are very tempting, are not for us. You see, they assume JDBC, synchronous blocking JDBC. So these are not a great choice. There is some hope on the horizon. There's some good options. There's R2DBC from the Spring team, which is a reactive SQL abstraction that works with natively reactive database drivers. It's not a facade on top of something that is blocking. It is a natively reactive database driver. So as a result, it is limited to those options that support reactive data access. It is also super early days. So do not use it in production, okay? It is an experiment. This is why I will not even write this code today. Instead, we will confine our choices to these things that support data access. And we have a number of different options here. Reactive Redis, we'll see this a little bit later. We have Reactive Cassandra and Couchbase, great, both of them great choices, obviously. And we have Reactive MongoDB. Because when you want to lose your data, and you want to lose it reactively, there's no better choice than Reactive MongoDB. So I'm going to go ahead and build that application. And I'm going to go ahead and hit generate. And that'll give me a new project here, right? I'm going to go to my downloads directory. Oops. Larger so you can see. Sorry about that. CD, downloads. There we are. I'm going to open this up in my IDE. And we're going to edit the program. And it's just a regular Java project. Spring Framework 5 assumes Java 8. So everything we're doing here requires Java 8 or better. I'm just using regular Maven. You can use that if you like. You can use Gradle. That's great as well. I mean, lots of options here. Okay. Now, what we're going to do is we're going to build an application that manages data of type reservation. It's going to be an entity that we're going to persist in the database. Can you see that font? That seems a little small. Let me make that a little larger for you, my friends. I'm sorry about that. There we go. 22. Can you see that in the back? Is it okay? Okay, tell me if it's not. I will make it bigger. We'll fix it. So we're going to build an application that writes data to the database. It's going to have a field called ID. It's going to be the primary key. Another field called reservation, or just called name, right? And that's going to be the entity. We're going to map it to a document ID, and we're going to call it a Spring Data MongoDB document. It's Java, so we need getters and setters and all that. So I'll use Lombok. Lombok is great for creating the getters, the setters, the equals, the toString, the hash code. All of this gets created for me at compile time using these annotations. And then finally, I'm going to write data to the database using a Spring Data repository, a reactive Mongo repository. And this repository looks very familiar if you have used Spring Data before. We support creating, reading, updating, deleting, and even custom finder methods. But you notice that these things are a little different. First of all, we take, instead of just a collection, we also accept a publisher. A publisher comes from the Reactive Streams library. It's a specification. It has 4 very simple types. This is the heart of what we mean when we talk about reactive programming in 2018. A publisher publishes items of data. A subscriber subscribes. It listens to items of data. Whenever there is a new item, the onNext method is called. Whenever there is an error, the onError method is called. And when we are done processing the data normally, non-exceptionally, the onComplete method gets called. Now, I skipped over this one. I skipped over onSubscribe. OnSubscribe is the most important one because this gives us a subscription. A subscription is a thing that we can use as a consumer to tell the producer to stop or to slow down, right? So think about what is happening. In synchronous blocking input and output, you pull the data out of the input stream, right? You read the data from the input stream, 1 byte buffer at a time. You control the rate at which you are reading that data. In asynchronous, non-blocking I/O, you're no longer in control. The publisher pushes. It pushes the data to you whenever it wants. Well, this is not good because it might surprise you. This is not a good thing, right? We don't want our publisher to say, oh, surprise, here's 5 terabytes of data. Hold on to this, right? Just watch your application fall over. It's not good. So we need some way to tell the producer, look, I can only handle so many records. I want to request N records. This is what we're doing here. We're saying I want X records more, please. And when I'm done with that, I'll request another 10 and another 10 or 1,000 or whatever. If you want all the records or as much as possible, you can just say long.max value. But don't do that, okay? I can also cancel the rate of consumption. So there you go. See that ability to push back? That's called flow control. If you've ever done any basic network programming, you have to think about flow control. In the reactive world, there's a marketing term called back pressure, right? It means flow control. It's not a new idea, but it's a very useful idea. So it's important to keep that in mind. So a publisher is the basis of all these reactive types. In the Spring world, we have a project called Reactor. Reactor is a project from Pivotal. It is underneath Spring, so you don't need Spring in order to use Reactor. And lots of different people just use Reactor by itself, which is fine. And the Reactor project has 2 specialized types. One is called a mono. A mono is a publisher that produces 1 or 0 value. It's like a completable future with reactive types, reactive semantics. And it also supports other operators like filtering and transformation and composition. We have another type here called a flux. A flux is a publisher that produces 0 up into infinity, up until unlimited records. So 0, 1, 2, 3, 5, a trillion, a billion, or it could just never stop, right? You could have a publisher that will produce new data as long as there is heat in the universe, right? So that's those basic types. Now that we understand this repository, let's write some data to the database. I'm going to just create an event listener here. I'm going to say when the application is ready, I want to process the data. So let's write data, right? Write data to MongoDB for demo. Thank you, okay? And we're going to create an exception handler that will just get initialized when the application starts. We'll inject our reservation repository like that and add that constructor argument to our application. And we're going to write some data to the database. So I'm going to say, I want to create some hard-coded names. My name is Josh. It's so nice to meet you. Let's go around the, let me think of some names here. I've got my buddy Stefan. There we go. We've got Mark. We've got Jane. We've got Madura. There we go. Madura. Okay. We've got Jennifer. Okay. So that's, what is that? That's 6 names. I think we need 2 more names. Let's see. What is it? How do you spell that, my friend? Like this? Oh, this one? B. Oh, like that. Well, how? I don't want to do it the wrong. Is that correct or no? Okay, nice to meet you. Very good. And I need one more. Miss, what is your name, my friend? Huh. Like this? Very cool. Nice to meet you. Very good. Thank you so much for all of that. I appreciate that, my friends. So there's some names. And what I want to do is I want to turn each one of these names into a object that is going to be saved in the database. So I'll say name. I'm going to turn this into a new reservation. Null ID name, okay? And that turns into a publisher full of reservations, reservation data, okay? Now I want to save each one. So I'm going to say map again. I'm going to say this dot reservation repository dot save, passing in the R. Now look at what map does. Map takes the result of this lambda and it saves it into the publisher that it is creating for us. Well, the result of the lambda is save, and it gives us a mono. So this is actually going to create a publisher of reservation. I don't want that, so instead we use flatmap. Flatmap will give us just a publisher of the thing that is nested, the nested type. So save data. Now, if I run this code, what happens? Well, you might have guessed that nothing is going to happen. You see, this code requires us to execute it. We need to start the processing. It's like the Java 8 Streams API. So you do that by subscribing. And I showed you that there is a version that takes the subscriber from the Reactive Stream spec. But there are some overloaded versions from the Reactor project, including one that takes a consumer. So we can just use that. We can say system out, reservation, like so, and we can say reservation.toString, and there's our updated code, like we said, and there we are. Look at that, huh? So let's go ahead and restart our code and see what happens. Oh, nothing. I have to compile. This is not Kotlin. Alrighty. Go, go, go. All right, so that worked. Of course that worked. It was a demo. What were you expecting? Of course that was going to work. There was no question in my heart or my mind about whether that was going to work. What I wanted to talk to you about was this. This is the ASCII artwork. Anybody who knows me knows that I care very much about ASCII artwork. This artwork took a long time to get right, but we on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue that said we need good ASCII artwork. And I think you can agree they did a great job. So it's for this reason, as always, that I want to just take a brief moment to talk about what I consider to be a very serious bug in the IntelliJ JetBrains product. Even though I am a fan, I consider this to be particularly short-sighted. Do you see this checkbox? This one right here? That one? This one right here? This checkbox? Do you see that? That checkbox, once you click it, it disables the ASCII artwork. What the hell? That's a dumb feature. I don't even know why that's there. So I did what everybody would do in the same situation. I'm not a hero. You don't have to thank me. I did what anybody would do. I went on the internet and I cried. And I was given a message of hope from my friend Jan Sabran. This is Jan Sabran right here. This is him right here. Boop. So he sent me this message of hope, which I want to share with you. And, it makes me feel better to imagine that this is going to be okay. He sent me this message. He insists, Josh, don't worry, it'll be fine. That'll be in the next release, Josh. It's going to be fine. Now, of course, that was 2016, so I'm not sure what that's about, but whatever. Anyway, we have amazing ASCII artwork, right? We've got amazing ASCII artwork. Now we need some sort of REST API, right? We've got an API. We need to be able to talk to it. So I can do that very easily. I can use Spring MVC style REST controllers. I could say like this, REST controller, reservation, REST controller. And I could just inject my reservation repository like so. And create a constructor, and I create an endpoint. And, this is all very familiar if you've ever used Spring MVC, except it's not Spring MVC, as we'll see in a second here, right? So reservation, get, okay, return this.rr.findAll. There we go. There's my REST API, very simple. Oops, maybe clean that up a little bit here. Make the compiler unhappy. Okay, so did I fix it? Start it again. And then in order to see that in action, you can just go to a shell, and we'll curl HTTP localhost 8080/reservations. Okay, so there's our data. That's fine. But you notice that there's a problem with this code. There's more records than the names that we had just put in there. You see, there's a problem with our code. I have this code, and we run into a very subtle bug. How many of you know the expression? Maybe it's the same thing in French. I don't know. But in English, it's very common to say a broken clock, or even a broken clock, is correct 2 times a day, right? This means that because the hands are fixed, they're not moving. In the AM and in the PM, that clock is correct. The same is true for MongoDB. Every now and then, it will save data. Not often, but it will. And so as a result, if we run this program 1,000,000 times, 2,000,000 times, we might have a duplicate data eventually, right? So I need to delete all the data first. I'll say this, .reservationrepository.delete all. And then I want to run the processing that I saw here. I'm going to clean this up a little bit. Then I'm going to clean up the data and just create one publisher full of data, like so. And that whole thing I'm going to put here. And then, finally, I'm going to say find all the data, and then finally, I'm going to subscribe to the results, like so. So what I have is very interesting sort of asynchronous code. This is going to delete everything first, and then it's going to write all the data to the database, and then it's going to get all the data from the database, and then it's going to list out the results that come back. And this is all going to happen asynchronously and potentially on different threads. We don't need to worry about that, though, because there is a scheduler behind the scenes that will make sure that the work gets done on whatever thread is available. Each thread is an event loop, okay? And so we don't really have to control or change that. We can, of course. We can say subscribe on and then provide our own scheduler. And this is great if you want to do something with like if you're talking to JDBC or something that is blocking, then you need to scale that interaction using your own thread pool, right? But by default, it's probably just fine to leave the default. Okay, so we have now a much better result. Let's see if I get that data back, like so. You can see there's much fewer records, just 8 records, as we expect, okay? So now what I want to do is I want to build a client to talk to that. A client that will talk to it for us and act as an edge service. So here I'm going to build the reservation client. It's going to use the reactive web support, Lombok actuator. We're going to use Spring Cloud Gateway, reactive Redis, right? We're going to be using Redis like I said we would. So where's Redis? Reactive Redis, we're going to use 2.06, so I don't have to download the world. We're going to use, what else do we want? Security, reactive Spring security. And I think that's it. I think that's probably enough for now, okay? I'm going to go ahead and hit generate. And this is going to be a new service, but it's actually a client to the service that we just built. It's going to be an edge service. It is the doorway for requests coming in from the outside to talk to our downstream services from actual clients like our iPhones and our PlayStations and our Xboxes and our Android devices and our iPads and all these things. All of these things and that one person using Windows Mobile. Okay, so here we are, 8081. I'm going to start on a different port. And I'm going to create an edge service. And edge services are great if you want to change or adapt different clients so that you don't have to change every single microservice. So for now, I'm going to comment out Spring Security because otherwise everything would be locked down. So think about what you can do at an edge service. Well, one thing you can do is to proxy data. Imagine you are building a HTML5 browser-based client, and the browser-based client requires access control allow origin header on all the microservices that you talk to. Well, if you want that, you can add it to every single microservice, of course, but the problem is that you have to change and redeploy each microservice. We don't want to do that, right? When we move to this architecture, we want to keep autonomy. We want to keep our ability to evolve the system without requiring other parts of the organization to change. So me building my HTML5 client, I don't want to have to ask everybody else to please change their code just because I'm building a client. Instead, I will deploy an edge service. And I can create a proxy using this new project called Spring Cloud Gateway. Spring Cloud Gateway has a very simple structure. You set up a predicate. I can say I want to match anything.foo.fr like that, and I want to match this path to proxy. And when it's matched, I want to send a request to, for example, localhost 8080, my service. But I want to change things about that request, don't I? So I can use filters. I want to say a filter that gets added to the processing chain. Filter.setPath will be reservations. Okay, very simple. I want to add a response header, don't I? I want to add the access control allow origin header to the request, right? Very simple example. Let's go ahead and restart that one. Compiling for the first time. Okay, so that's up and running. And now I can see the application. If I make that request, curl HTTP localhost 8081 / proxy, this will fail, won't it? It's going to fail because I don't have the host header. So -h voxt.foo.fr, right? Oh, host voxt.foo.fr. There we go. There's the data. Okay. But if I change this to not match, like this, com or something, then I get a 404. So I'm proxying the data. But let's go back to the data here, and let's do -v. And when I do that, I can see, okay, access control allow origin is equal to asterisk. Now my HTML5 client can talk to this edge service even if it is deployed on a separate host and port. The browser, cross-origin request scripting limitations have been lifted. This gateway is reactive only. The Spring Cloud Gateway is built on the reactive support in Spring Framework. It assumes reactive only. There's no way to do this in a servlet-based application. And that's an important point, I think, here. I didn't mention this, but this is not a servlet-based application. This is something called Spring Webflux, and it is running on Netty. There's no Jetty or Tomcat or anything here. It's reactive end-to-end. Okay, so we have now a simple gateway. Imagine I had some other service downstream, something very slow that falls over very easily, and it falls over, right? If there's a gust of wind, it falls over. Something that just needs to be protected, something that might fall over if there's trouble, right? In this case, I want to protect that downstream service. And the way you can do that is to use a rate limiter. So I'm going to configure a rate limiter here. And this rate limiter is going to protect my downstream service. In order to do that, I have to keep a count of how many requests are coming through and how many I allow to go through. So I'm going to use a rate limiter that stores the data in Redis, the data structure server. I've got Redis running in the background here. So I'm going to say I want to have 5 requests per second bursting into 7 seconds per second, okay? So here I say Redis rate limiter config.set rate limiter, Redis rate limiter. All right, now the question, of course, is Redis is a distributed key value data store, right? There's keys and there's values. I have a number that is the number of requests coming in per second. I need to tell my rate limiter which key to use for the data. So I need to give it a key resolver. So I say set key resolver. And a very common thing, you could just say mono.just my static count, like that, no problem. But what if I want to be a little bit more dynamic? Maybe I want to say, oh, well, let's look at the current principle, the Java security principle. And I'm going to map the principle. I'm going to say principle.getName. And if there is no principle, then I'm going to return with just an empty publisher, an empty publisher like that. That's a very common strategy, very common. It's so common, in fact, that we have a built-in version called the new principle key name resolver. And it's so common, in fact, that this is the default. So we're back where we started, which is nice. Now, in order for this to work, we need security, don't we? We need to use reactive Spring security. And so we are going to bring in our dependency here on security. And we'll bring that back in. Now, Spring Security answers 2 questions. Authentication, who is making the request, and authorization, what can they do once they are authenticated, right? So to answer the first question, I'm going to create a hard-coded list of usernames and passwords, like so, authentication. Now, this is a map of users and details. So I'm going to create a user, JLong equals users.with users, come on. Users dot, wrong import. No, that's the right one. Okay, users with default password encoder dot username equals JLong dot password will be password because of course it's password. And user will be the role, and I'm going to build it. Okay, now this is going to be one user called JLong, and I will do another one here for Spring Security Lead Rob Winch. Rob Winch, this is him. This is Spring Security Lead Rob Winch. Now, Rob Winch, he lives in Kansas City in the United States. And you see, I give this talk. I perform this talk for people all around the world. I care about security, so I talk to people about security everywhere in the world. And it's very strange. He's in Kansas City, which is, it's sometimes I'll be in Asia. Sometimes he'll be in Africa or South America or Europe or whatever. He will be asleep a lot of the time. It's nighttime where he is. And something very weird, something very strange happens every time I give this talk. Suddenly, for no reason at all, Rob Winch starts tweeting, right? And I didn't understand why. I didn't understand what was happening. I did some investigations for reasons that he will never understand, that he could never hope to understand. Every time I do something terrible like this, where I have hard-coded usernames and passwords in my Java code, every time I do this, for reasons that will always be a mystery to poor Rob, every time Rob Winch becomes sad. It wakes him up out of a sound sleep to know that I'm doing this thousands of miles away. So my friends, don't ever do this. This is a demo, okay? Now, that's my authentication. We need to do authorization as well. I'm going to use a filter. Whoa, easy there, easy, too fast. Security web filter chain, authorization, server HTTP security. I'm going to say http.authorize. Well, first I'll say CSRF disable, HTTP basic, great, HTTP.authorize exchange. And the authorize exchange is me telling Spring Security what endpoints I want to allow. So proxy will be authenticated, and any other thing will be wide open. Okay, I'm just going to let it go through. And then with that done, I'll build and we'll start the application and we'll see what happens. So now I have a rate limiter with some security configured on this path for the proxy endpoint. Okay, so now curl minus h host is vox.foo.fr http localhost 8081/proxy, okay, minus v, and you can see it says 401 unauthorized, okay. Now we do minus vu JLong:PW. I'm doing HTTP basic, okay. Now I have my data, that's working. And you can see I got rate limiting headers, X rate limit, remaining, burst capacity, and replenish rate. So now I want to make those same requests in a loop. I'm going to drive some traffic using bash, as much as I can anyway, using slow bash. Okay, so I'm going to drive a little loop here to hit my endpoint. And as I do, you can see here, it worked. I've got some data. I've got some data. There, it did not work there. It says 429 too many requests. It rejected the client request to the downstream service. It protects the slow, fragile downstream service so that if it gets overwhelmed, we can protect it. So this is a very simple use of the gateway. Now the gateway is great for cross-cutting concerns, things that you want to do generically across all microservices. Another thing that you may want to do is adapt data. You can use a API adapter instead of an API gateway. And in our case, let's build a simple application, a simple endpoint that produces a response using the functional reactive style here that will return just the names. Just the names, okay? So not the whole reservation JSON, just the names. So I'm going to say request predicates.get/reservations/names. Going to provide a new handler function. And the handler function is going to produce a response that we listen to. Now, of course, I'm going to clean this up a little bit, add a static import, add that static import there. And our job in this reservation names endpoint is going to make we're going to make a call, a reactive call, another REST call to our reservation service. I'm going to have a reservation client that returns just the reservations. Well, of course, I don't have this type on my local class path. So I'm going to do something terrible, something that you should never ever do, ever. Not even when you are all by yourself at home, all alone, and no one is looking. I'm going to copy and paste some code. So there's my reservation entity that I've copied into my application. I'm going to use that to get all the reservations from my service, right? This is going to be a very simple publisher, a client, and I'm going to use the Reactive Web Client, okay? The Reactive Web Client is a HTTP client that's fully reactive, and I think it's a much better choice today because you can use it to create reactive streams where you can compose data. You can call this service, and this one, and then compose and combine the data that comes back. So I will say return this.webclient.get.uri HTTP localhost 8080/reservations. And I'm going to say I want to get the data. I'm going to turn it into a JSON publisher. I'm going to turn it into a publisher full of reservation data. It's going to take the JSON that comes back and turn it into this data. And I will use that here. I'll say I want to inject in my functional reactive endpoints. I'm going to inject this client, and I'll say create a server response .ok.body, passing in the client. Now that client data, I'm going to map it. I'm going to take the data. I'm going to map the data from a reservation to just the reservation name. Okay? So there's my name, full of data, my publisher full of string names. Okay? And I will say, pass in the names, string.class. All right, so this is like Spring MVC style, but it's functional, it's reactive, it's a nice API. You can use both. You don't have to choose one or the other. I'm using this because I think it's a very concise, okay? And you can use both in the same application. Now, this is nice because this is a builder API. You can dynamically add things to the application. Oh, it's saying I need a bean of type web client. So let's go ahead and create one of those as well. At bean web client. And I'm going to create the reactive web client like so. Web client.builder.build. Et voila. Okay, restart. Create that bean. Spring will see it. It'll inject it for me in this web endpoint. And there we go. Now, the application, let's see the endpoint here. Curl HTTP localhost 8081/reservations/names. All right, so there's our names that came back from the reactive stream. But it's an API adapter. We didn't get the JSON. We got the names only, no IDs, nothing else, right? It's a very simple example. We have a view of the data that is specific for a client, okay? Now, this may work most of the time, but if that service does not exist, if this downstream service is gone, if it's failed, if the load balancer cannot load bounce, then it's going to fail. So I want to make sure I have some robustness. One thing I could do is I could say, okay, I want to retry, 10 times if it fails, or I could do a on error. I could say when there's an error, of type illegal, whatever, like this, any kind of thing here, and then I could say, process it like that, or on error resume. I could even change. I could resume the processing like this. So I have lots of operators that I can use to make the code more robust. But those are very simple. They don't have the smarts to see that I am going to try and make the same call multiple times. And so do I have that here? Do I have the circuit breaker? No. I'm going to add a circuit breaker to my application. Spring Cloud Starter Netflix Hystrix. All right. And that's going to be a Spring Cloud dependency. Very good. So Spring Cloud Starter Netflix Hystrix. Very good. Now, what I want to do is I want to wrap that command. I want to wrap this publisher in a circuit breaker. And if the circuit breaker sees that we have made an error, there's an exception, it'll give us the fallback value, right? I'm going to make it, I'm going to give it a name. I'm going to give it, I'm going to say it's eager, and then I'm going to build that. And that'll give me a publisher that wraps my actual publisher. So I'm going to use that here instead. So now if something goes wrong, the fallback value will happen, okay? Let's try this. Now, if I make this request here at the reservation names endpoint, we should see that the service works just fine like before. Now if I go back to my service here, I'm going to kill this. And it's almost Halloween, so watch this. See this scary little skull? Ready? Very scary, huh? Huh? It's like PHP code in your... Ugh. So there we go. We've got now the application. And I'm going to start the application, make the call, and I get eek. Okay, so we degraded gracefully there. It's a very simple example of creating more robust microservices. Now, so far we've got like 6 minutes. We're ahead of time. We can relax. I feel like this has been very good because we got to see building HTTP-based microservices. We got to see how that works in the Spring Stack. But I want to talk about something that's very exciting, very new, and that I've been wanting to talk about for like a year, but we couldn't really because it was kind of like, shh, Last month, a few weeks ago, at our big conference, Spring One platform, which is not as good as this one, of course, but it's an okay show. At that conference, we announced our support for OurSocket. OurSocket is an open source protocol from Facebook. It was started by Ben Christensen and the team over at Netflix. And Ben Christensen, of course, he created RxJava. He went to Facebook and he took this idea of reactive streams and he created a protocol based on that. Facebook used this protocol everywhere, right? There are 3 different bindings, client-side bindings. There's one in JavaScript, one in C++, and one in Java. The Java binding, of course, uses Reactor, right? And so it's a very nice fit for reactive Spring-based applications. So what we're going to do is we're going to change our code here a little bit. I'm going to bring in the RSocket dependencies, like so. CNJ RSocket dependencies. Okay, PB copy. I'm going to paste this into both my producer and my consumer. Now, Reactor is in a lot of different places, right? I'm showing you HTTP, but this is a new protocol. This is not HTTP. And you don't have to use OurSocket either. There's lots of options here in both, in the Reactive world that are all supporting Reactor. So, for example, if you wanted to use gRPC, gRPC is a thing from Google that does RPC-style interactions. You can use that as well. They have the Salesforce, the company called Salesforce. They have a Reactor gRPC-based binding. It compiles to reactive gRPC services based on Reactor, right? So you can do that as well. That's also web scale, right? But I'm going to use OurSocket because OurSocket is really, really interesting to me. It does not have a particular, it's not RPC. It's a protocol for doing message exchanges. It can be fire and forget. It can be request response. It can be streaming data. You could stream like WebSockets. You can do full multiplexing, duplexing, channel-based streaming. You can do all sorts of interesting things. So I'm going to re-implement this service. And in the service side here, I'm going to create a new RSocket thing, class RSocket controller, and I'm going to use a component, and I'm going to say when the application starts up, I want to be notified, and I'll serve this RSocket service when that happens. I'm going to inject my reservation repository. Now, this is a little bit rough. This code that I'm going to write, this is more code than you should have to write. In Spring Framework 5.2, which is not out yet, we will have built-in support, just like Spring MVC, for this protocol, okay? So new socket acceptor, and our job in the socket acceptor is to create a RSocket object. So I'll do that here. RSocket, new abstract RSocket, and when we extend this, we're given several different methods: request response, request stream, request channel. We can do fire and forget, all sorts of things. What I want is a stream. I'm going to stream data backwards, okay? And with this, I will say reservation repository.find all, and when the data comes back, I'm going to map the data, the reservation data. I'm going to map it into JSON, a little string. RSocket does not care about what the payload of the data over the wire is. It's a binary protocol, but it doesn't care about the envelope, the data in the envelope itself. So I can say this object mapper dot write value as string. I'm going to turn the reservation into a string. That requires try catching, of course, in Java for reasons I don't understand. Okay, and then I'm going to turn that string into a default payload object. So there we go. I'm going to just turn that into a payload object that I can send back over the wire. So there's my RSocket. I'm going to say mono.just RSocket. That's my socket there. I'm going to send that back. And I can put that in here. So I say socket acceptor. And I'm going to provide a transport. This is a TCP server transport. TCP server transport.create 7000. I'm going to listen and port 7000, separate port, right? Not HTTP after all. TCP server transport, and then I'm going to start, and then I'm going to subscribe to the data. I'm going to listen for the data coming in for the requests. So that's my server side. Okay, let's go ahead and start that. On the client side, I need to do the same kind of thing. And so what I'm going to do is I'm going to create a new reservation client, comment that out, and we'll just create a new one. Same contract, nothing needs to change. But here, I'll say TCP client transport equals TCP client transport 7000. And here, I'll change this code. I'll say RSocket factory dot connect dot transport, this dot transport dot start, and I'm going to flat map the data. So I'm going to be given a pointer to a valid client-side RSocket. So I'm going to say RSocket dot request a stream. So I'm going to make a request to port 7000. The request will have nothing in it, so I'll just do a default empty payload like this. Default payload dot create new byte 0. Okay, and we're going to take the payload that comes back in the response, the publisher, the Reactive Streams publisher. We're going to take that payload, and we're going to say payload get data. We're going to take the string that comes back, and we're going to unpack it into JSON, and then that JSON I'll read into a Java object, just like we did with before, but this time we're using the object mapper for the client side, aren't we? And so I'm going to inject that there. This object mapper read value JSON as a reservation class, and of course that requires a try catch handler, throw new runtime exception, e. Okay, so there's my code, and return that. So that's my client-side code that's going to make a call using OurSocket to the service. Everything else is the same. The gateway, the circuit breaker, the reactive endpoints, the reservations, names, endpoints. So if I have an actual iPhone or HTML5 browser, they still talk to the gateway using HTTP. But my service-to-service communication can be over this much more efficient binary protocol that's powering Facebook. So localhost 8081/reservations/names. Et voilà. Merci, mes amis. I think we're just about out of time. I hope you got something out of this. Did you learn anything at all? Anything useful at all? Anything? Anything you could see or practice? Okay, good. Very good. Merci d'être venu. I'm so happy to meet you all. I'm happy to answer questions afterwards. Thank you so much, Vox Microservices, for having me today. It's an honor and a privilege to be here. Merci. Merci mille fois. Beaucoup. Merci beaucoup.